The purpose of this video is to demonstrate how to use Google Earth to locate the epicenter of an earthquake. For this activity, you're going to need to download the Google Earth Pro version and not use the online version, as the online version doesn't have all the necessary tools that we need to perform this activity. Okay, so how do we go about locating an epicenter? There's actually kind of three steps that you're going to be taking. The first step is we need seismic data from 3 seismic stations. Okay? Using that seismic data, we're going to determine the difference in arrival times from the P and the S wave of those 3 seismic stations, and then we're going to use that to determine the distance from each seismic station to the epicenter. Through the process of triangulation, we're going to see where all those distances intersect, and that is the location of our epicenter. So what I'm going to do for you now is I'm going to model for you how we go about doing this using seismic stations. All right, the first station that I'm going to use is I'm going to use the seismogram from Boston, Massachusetts. What you have to do first is we have to determine the difference in arrival times of the P wave, which arrives first at the seismogram, and the actual S wave, which arrives second. Seeing as how the vertical lines have a difference between them of 20 seconds, and in the lab I stated that the seismogram begins at 6 p.m., this is 6 p.m. and 20 seconds, 6 p.m. and 40 seconds, 6:01, 6:01:20, and 6:01:40. So this is where the P wave actually arrives, at 6:01:40. As you continue on counting through, you will notice that the S wave arrives in this case at 6:07:20. Okay, so if we subtract 6:01:40 from 6:07:20, and remember we're using concepts of time, so don't do it like normal math, you have to do it in 60-second intervals, what you end up with is you're going to end up with a difference of 5 minutes and 40 seconds. So using this information, we can now determine how far away is the epicenter from Boston, Massachusetts. To do this though, what we need is we need to bring in our P and S wave time travel graph. And now we need to find on this graph where the arrival time of the P wave and the S wave have differences of 5 minutes and 40 seconds. Using the methods that we've, in other videos where it says you line up a scrap piece of paper and you put a dash at 0 and a dash at 5 minutes and 40 seconds, and then you drag it up the seismic, the P and S wave time travel graph, what you will notice is you'll notice about right here, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, and 40 seconds. So right along this vertical line, we have a difference of 5 minutes and 40 seconds. What that indicates is that this seismic station, Boston, Massachusetts, is 4,000 kilometers away from the epicenter. So now what we do is we go back to Google Earth and we'll go up here and we'll go ahead and type in Boston. Okay? So with this, what it's going to do is it's going to go ahead and take us to Boston, Massachusetts. Okay, so right there it is, and I'm going to stop it halfway in so we can see it well enough right there. Then I'm going to go up to my ruler tool, and on my ruler tool you can see it's probably going to come up to line. I'm going to go ahead and select circle. What you're going to then do is to make sure, it can be in centimeters, it can be in meters. Please make sure that it's in actually kilometers. Okay, and so now I've got it set up perfectly. You can see that I have my highlighter right there. So what I'm going to do is I'm going to scroll in, and then I'm going to put that in the center of my bullseye and left click. As you can see now, as I start to drag, it's creating a circle around Boston, Massachusetts. Well, my task is to create a circle of 4,000 kilometers. So that's what I'm going to do now. Now with this, we need to get it as close as possible. Now I realize that with Google Earth, you're not going to be able to get it exact. So you just say, okay, I've got it close as possible right there. I left click, and now it is actually held that circle right there of 4,000 kilometers. What I want to do is I want to save this now. Okay, so I'm going to go up here and I'm going to go ahead and type in Boston, and then I'm going to go ahead and leave that color right there as the selected red. I'm going to click OK. All right, so now what I know is I know through the process of triangulation and understanding how earthquakes are plotted, I know that my earthquake is somewhere on that red line. So what I need to do is I now need to basically do the same exact process over for another one of my seismic stations. So for example, we're just going to simulate this because I'm not going to go through the process again of how you do it for each city. But let's say Denver is my next city. As you can see there, it's starting to take me into Denver again. I'm going to go ahead and stop it. And now what I'm going to do is I'm going to use a seismic station or the seismogram from Denver to determine the distance to the epicenter from Denver. Let's say that I have a difference in arrival time of, let's just say 3 minutes, okay? Well, with that 3 minutes, using the P&S wave time travel graph, I now know that from Denver, it's about 1,900 kilometers. So again, I'm going to go to my ruler tool, and I'm going to get this out of the way, set it right there on Denver, and then I'm going to go out to a different distance of 1,900 kilometers. I'll go ahead and scroll out some. There we go. And again, I'm just trying to get it as close as possible using the tool that I'm provided. And I will call that good. Okay, so now here's what we actually see. I'm going to then, of course, save this one. Okay, I'm going to save that as Denver. And this one I'm going to change the color because it's also red. I want to change the color to, I'll just make it yellow. And click OK. And OK. So now what I see here is now I've got 2 circles on there, and what it's done through the process of triangulation is it's narrowed me down. Okay, so it's narrowed me down to these 2 points where these circles intersect. So I now know that my epicenter is either right there or it is right there. So of course what I do again is I just I do the same exact process again using a different seismic station. I'm just going to choose a city of randomness so that I can show you how to do this. So I'll just put it right there. I'm going to go out. And I'll make it more realistic. Okay, so let's say that the city that I chose there, its distance was that 2,500. Okay, so here's what we're actually looking at. I go through the process again. Random city. And now what I see is I see where all 3 of these intersect. Where all 3 of these intersect, that is actually the location of my epicenter. Now, what I want you to know with this is sometimes you're not going to get a perfect intersection, okay? Just because of accuracy of what the distance is to the epicenter, you can actually see a point where they come really close to intersecting. So you're going to end up making like a little triangle right in this area, which is totally fine, so don't worry about it. Your next step though is you want to make sure that you highlight it. So we're going to go up here and we're going to add a place mark. I'm going to choose that place mark and I'm going to now drag it over, put it right there, and then I'm going to call this my epicenter. Click OK. Okay. So now what I've done is I've got my plot and I've got the location of my epicenter. I'm going to come up here now and I want to go ahead and save this. So I'm going to save it as a KMZ file. Okay, so I'm going to click Save, Save Place As, and then you can see where you're going to have it. I'll just save it to my desktop. And then I'll put my name, and then Epicenter. And then I'll go ahead and save that. And so now that you have that file actually saved, this is what you're going to upload to the one of the questions in the assignment, because then I'll be able to open your KMZ file and see your exact plot. That's what I am looking for. I'm not looking just for the location of the epicenter. I am looking to see, to make sure that you have these circles, which tells me you understand the process, and then you understand how the epicenter of an earthquake is actually located by looking at where the 3 points intersect. So hopefully this video will help you in completing the activity, and it also can help you, understand how we go about locating epicenters. Have a good day.